Welcome to the day two of Tech Nexus and Flutter Forward. Yesterday, some of you might have attended the TensorFlow event, and you might have seen cool collab files, but not the user wants to see the cool collab files. They want to interact with the interface. And today we'll be doing integration in the Flutter application, specifically in the Flutter application. So let me know in the chat, if anyone have already integrated machine learning into any mobile application before, and how many of you know actually Flutter? Put that thing into chat already. So there are some prerequisites for this session. So you should be able to know basics of Flutter. You should be know how to design a screen and how to make a UI, a simple screen, and any state management. We'll be going to the provider. It's actually simple. I'll be explaining you that in the session. All right. What do you guys think is the ways to actually integrate machine learning? Any responses? What do you guys think? How do you integrate machine learning into Flutter? Let me see. No responses. Me and Aryan has been going to a lot of hackathons, and there has been no hackathon where we have not integrated machine learning into app. All right. No issues. I'll be telling. Uh, let's say you are an app developer and your friend is making an ML model. And if it's a really good friend of yours, what he'll do is he'll create a server and an API. So you can use that API to actually integrate into your Flutter application. That's way one. So the way one, wait a minute. So way one is you have a server and where the model is running and you can interact with an API calls. And the another one is that you don't have it separated. You can actually embed the model directly into the Flutter application. That's the second way. You can use any kind of a dumping. Today we'll be going through Tensor TF Lite, which is a TensorFlow Lite models, which is a dumping way. And the third way is actually using a pre-trained Flutter packages. So there are common use cases. Let's say a OCR recognition or a speech recognition that uses a pre-trained model, or you can directly use in Flutter package to integrate. These are the basically three ways you can use to actually integrate machine learning. So the first way is using API. So what is an API? So API is like a application programming interface. It's like a messenger between two software systems I discussed, like a server and your mobile application. So to actually understand this better, I'll take an analogy. Let's say you went to a restaurant and you want to order something. To order something, you need to communicate with the chef. But to do that, there is a middleware which is known as waiter. To you give a request to a waiter that I want to eat this thing, and the request is being carried by that waiter to the chef, and the chef processes that request and sends you the food in form of a response, and this response has been carried by that waiter. So that's the purpose of API here, which can be understood through this simple diagram. So this client will be our mobile application, and the server is where our memory model is running. So this API will be used to actually send a request and receive a response. Lot about this PPTs. Let's go through. I'll show you some example APIs. So this is a basic GET request. So there are different types of REST APIs. So the first one is get, post, and put and delete. So all serves different purposes. The GET request is a simple API where you can get the response. You don't have to pass in any body and something. So this is a simple GitHub API where I've passed in my own username and I've got a response here about let's say followers and following. So this is another Hugging Face API that I found. This actually compares two sentences. This was a body, and the body is in form of JSON. So this takes in this kind of a format. This is a particular format of the body that it takes, and these are the sentences that it compares and gives the scores out of it. You can find an endless amount of APIs there in the Get openly available APIs. And this is the API that we'll be working today. This is customly made by Aryan Surve. And this takes in a body, like let's say a number of hours that you studied and gives a predicted output, like how many marks you can achieve, and a meme kind of a image URL. All right. So I've created a basic template here. I'll just show like from the main screen. I'll just show the screen. Today we'll be actually using a provider to actually manage the state. And I'll show you the prospect.yml as well. So what kind of dependencies we are using here. We are using these two dependencies. The first one is to provider is to manage state, and the another one is SCTP to actually do the network request. That's all right. So basically, I am having a main function where I'm calling a run app, and this run app takes in a widget where I'm passing my app. All right, and I have wrapped my material app, and which is which is having a home as my prediction screen, and I have to wrap this whole widget with a multi-provider, which wraps the whole widget tree into a state. So each state classes which I have in the provider is accessible everywhere in the widget tree. All right, I'll just show what the mark screen have. So mark screen is a simple screen where I have a art bar which shows marks prediction, and it has a text field here which takes in the marks, and I can control this with using this controller. All right, and I have a button that calls a callback function, but I have not implemented that, so I'll be coding it right now. All right. So to code that, I actually show you what my folder structure looks like. All right. So this is my lib folder, and this was my main class. And in the presentation, I have my all my UIs, and in the provider folder, I have my state management classes, and the utils I have some common utilities. All right. So in the provider, I have this marks detection screen. This was the screen that I explained. And in the provider class, I have this marks prediction class. So this is actually a provider class which manages the states. What are the states? The state is something that changes in your screen. Let's say I want to predict and I get the prediction score. This will be a state of mine. And the image URL will also be a state. All right. So there are other states that you can think of. Let's say while the request is processed, there will be a is loading state. So I'm going to keep all my states here in this class. And all the function related to that state will also be kept here. And this class will actually be used everywhere in the code in the widget tree where I want to use it. So what the beauty about the provider is that whenever you call a notify listener function, it actually updates the states. So you have a control over when you want to change the variables and when you don't want to do that. So we'll be integrating this particular API, uh, this marks prediction. So this is the base URL, and this is the predict route. On this URL, this is a post request, and in the post request, I'm passing in a body of a JSON that have a key pair of study hours and file. This will be my body, and this will be my response that I will be receiving. To integrate that, I'll go to my provider class and I actually make some few variables. The first variable will be string predicted marks, right? That will be empty currently because I don't have that response. And another one will be the image URL that I'm getting. All right. And actually to show the loading screen that the image has been processed, the request has been processed, I'll also have a uh, Boolean variable. I don't want to happen to me. Yeah, is loading is equals to false. And all right, these are the states. But to actually get this state, I need to have a function that I'll call it from my screen. So I will have to pass the marks that I entered in the text field in that function. So what will be the return type of this function? So that actually will be void because I don't want to return anything. I just want to update the state inside of this state class. So get prediction will be my function, and I'm keeping all my states as public, no access modifier, because if you want to keep this thing not public, you can keep it. You can utilize getter and setters. So in the prediction get prediction function, I'm going to pass marks, right? So I'm going to be passing as marks as a parameter. Now, okay, my Copilot is on. All right. So I will have a loading. So before I start, I will have to um, make change the state of the loading. So wait a minute. I'll just change the Copilot. I'll switch off the Copilot. All right, let it be. This loading is going to be equal to true because I'm processing that request. And a notify listener will be actually used here to my tab. Notify listener to actually notify that this request has been processed. Now you need to load. You need to show some changes in this UI to that shows that it is loading. All right. Now I'm going to have my URL right now. So the URL will be a string. The URL will actually be this URL. Okay. And so there are several components when you are building and API request. So this is the first URL. And the second thing is like you need to have a header. So header is actually a map of string. So I'm gonna create string that actually defines the type of your JSON in the body. So that body could be anything. Let's say it could be XML, it could be JSON. So you need to tell that your content type will be an application JSON. Slash JSON. This is something that you have to do, which was done here. I'll just show. In the header, it actually have accepted everything. Here it was okay. So, but in the Flutter application, you have to tell that it will be a JSON and your content type will be in JSON. Now you need to define your body. The body will again be a map of what the body looks like over there inside the. So I'm going to create. It was a string slash int, and it was the key was marks. No, the key was are studied. Right. So I studied will was the marks, and I got the marks from this parameter. So I'm gonna assign that. Since I have my body and header prepared, let's try building our API request. So that API request will be fetched from this HTTP library, and HTTP library is this package there provided in the Flutter that you can use. So you get a response in when you do a request. So this function sends a request, post request. So this was a post request, and you can't pass in the URL inside of this. So URL is like a shorter term of the URI. All right. So URL is like universal resource locator, and URI is for any kind of URL is only for the network, and URI is like for URN and URL. It's like a broader term. You have to pass that, and now you can set the header that we defined in the above function. And so body is a map, but the response doesn't understand dot here. It has to be, you need to encode this thing into a string. So that is a already predefined function that you can use in dot, that is JSON encode, I guess. Yeah. And you can pass in the body over here. So since you have this request ready, once you hit it, it will take a time. So you need to have await here. And you can't use await since your function is not async. So I'll assign async here. All right. So once you do send the request, you will get a response. A response has several other parameters. Let's say it has a status code. Status code tells the how was your response. If it is 200, then your response was successfully processed by the server and you received the response. So here I'll just try to print the response.body. Response.body actually contains the information that you are interested in. Yeah. So that's done. I'll just call this function and let's see if we are getting the body response from the screen. So this was the button that I have, predict button, and in the onPress function, I'll call this thing. So to actually use all the function and variable of that class, I have created this variable in a reference object of that class. So this is how you do that in provider. Alright. So this is generic provider of marks provider. Right. And to be able to use that, you need to tell that in the widget tree, I'll be using this provider. So which I've tell in here, you have to define what kind of provider you have. So using this instance class, instance of that class, I can access all the method that I've defined and variable that I've defined over there. So using marks provider dot get prediction. So I have to pass in the prediction. So I can get the prediction there inside of the text controller using this controller field. If I just see the text controller, so text controller is defined here. I've just control click on the text controller and it has a text parameter. Yeah, you can get the text there inside of the text field. So you can get the marks here using the controller dot text. Right? But this is a string and you have to pass, I guess, the end over there. All right. So what I'll do is this end dot pass that thing into uh, the function. All right. So since this is done, I'll just send this request and let's see if we're getting the response in the console. Okay. I've not passed anything here. Let's say 3. It's taking a quite time. Let me see if this function, I'll just add a debug statement in there. All right. I just send the request and the sending has been called. And let's see if we're getting the body. I'm not getting the body here. Wait a minute. Um, so I did receive the response. It takes a little time to actually process. All right. Okay. So we are getting the response. I just need to extract its data and present it into the UI. No. So what I'll do, I'll just check if the response has been successful. So that I can check that using response.status code. So the status code is 200. then I can update the state variables and show that thing into the screen. All right. So, but before the response was a string, that's why I was able to print that. So I need to convert this thing into a map uh, of this thing. All right. So this was the body. This was the data, let's say, that I received, and I need to JSONly decode it. Here we encoded this into the string. Now I have to decode the string to the map again. All right. Yeah. So once I've got this, I can update the states here. So I can access this class using this, and I'll just change the image URL to data that I received. Data is a map. So what was the key value? This was an image URL key value. So this was a key. This is the value that I received. All right. And I've changed the image URL state. And now what I'll do is I'll in change the state of predicted marks. And I have to check. It has to be same. Since the key values to be accessed, the key it has to same. It has to be the same. Okay. Since this value was a number or a double value, I have to convert that thing into string here. All right. So I've got both the things. Now what I have to do is like I have to stop that loading since I've got the response. So what I'll do is like this dot is loading is equals to false. Now once I have updated all the states, once I've got the positive response, I have to actually notify all my widget listeners that you can update the states. All right. And else you can show error once you didn't got a positive response by printing an error. You can handle it using any way you want. And I'll also is I also stop the loading here as well. Okay. So this is done, and I can now access these variables to actually show changes in the screen. Okay. So I've written all the state code. This was my predicted marks that I'm receiving in the response body. This is the image URL that I'm receiving again from that prediction, and this is the is loading screen. If I go in the screen of mine, below the elevated button, I'll just show all the predictions that I have made. So I'll just first check that if it is loading is equals to true. So I'm using ternary operator. So it's like a concise if else statement. So if the loading is true, I'm going to show a simple circular indicator. And if not, then I'm going to show column. And in the column, I'm going to have like two things. First is going to be a text that shows the prediction score. All right, the prediction marks and plus I can access that from the marks provider instance using marks provider, accessing again my access marks provider over there. All right. Okay. And I can also show the image that I received. It was a URL, so I have to use image.network and I can show the image URL. All right. Since this is done, let me just save it and I'll just process the request. It is showing loading. And wait a minute, I'll just check the variable state. So this is false, and I am making it true. And if I got the response, I'm gonna print false. All right, cool. I'm gonna send the request. So I got the response that I'm less studying less. All right. So this was the first way. It could be anything. So you might have used linear regression or anything as a simple model house prediction. So this could be you can make a server and make a API and connect it using an API. So Aaron now is going to explain the second way, which was embed a model directly into an application. This was the first way. Over to you, Aaron.
Yes. So as Abhishek said, that we are going to dump the model directly into the Flutter application. For that, the Flutter supports with the help of TensorFlow models, which is TFL. So what is TensorFlow model? If you are familiar with machine learning concepts, you will also be familiar with the concept of tensor. For your basic information, TensorFlow is a framework developed by Google, which gives you various types of resources and tools to develop your machine learning and deep learning model. It is mostly famous for various tasks like image processing. Then we can build computer vision, NLP processes. That all highly computational tasks are provided by the TensorFlow. So integrating this model in Flutter is very really difficult. So the TensorFlow has provided with a lighter version of their model, which is the TF Lite model. So TF Lite model is computationally also less computational, and it takes less mobile resources. So it can be directly integrated in a Flutter and Android applications. So uh, I am going to show you the simplest way to integrate the TensorFlow Lite model into the Flutter application. For that, I will show you a demo of image classification task. Just let me present the screen. Is my screen visible?
Yes,
Abhishek?
yes, yes. Yes, yes, it's visible, Aaron.
Okay. So for this, for using TensorFlow Lite in Flutter, we would have some prerequisites like we have to first import some libraries, that is TF-Lite version 2. TF-Lite version 1 is currently deprecated, so don't use TF-Lite, just TF-Lite. Use TF-Lite version 2. And we will be also requiring a package called as TF-Lite Flutter. This package help us to integrate TF-Lite functionality directly in Dart code. So for the image processing task, I will show a simple example of teachable machine. So these are the teachable machine. If you give some classes here, like cars, mm, airplanes, and for example, ships. Okay, I have given class and I will upload some images here. Images or any type of data. It can be an audio data, it can be a video data, like that. And it will train this model and it will give an export option of TF Lite model. So if we will export this model and it is an image classification task, it will give you a TF Lite model as well as the labels of the TF Lite model for identifying what is the current object showing in the screen or on the camera. Okay, so I have done this process already. So I will show you the code directly. So I have downloaded the model, which is currently running on three classification: cars, airplanes, and ships. And these are the label file of that. Okay. So after that, we will start integrating the. I will start doing the code. So first, we will import the libraries that we are required. First, we will import the Dart IO library, which will handle the file systems. Like we are using images for this. So where do we get the image from? It is from the local device or network image. So the Dart IO library handles this. After that, we will import the TF Lite version 2 for getting the functionality of TF Lite. Then we will import the image picker library because we have to use images from our gallery. For that, we need any UI and any functionality UI UX for that. So image picker library gives us the response for that. And finally, the material UI for our basic UI system. Okay. So for this Flutter app, we will be using the stateful widget image classifier. Okay. So uh, so basically there are some prerequisites for this also. Your minimum SDK version for running the TF-Lite model should be 26 or above. If it is below 26, you will get an error. So make sure you update that in your Android app build.gradle. Okay, and you have to load your model in the assets folder and the label.txt file also there. So for using this model, we have to first load the model, then we have to pick the image, then we have to classify the image. These are the three main functions for this code. So starting off with that, I will first take a image, we'll declare it as data type of file. Then for our result, classification result, we will take a variable in string, which is not empty, classification. Okay. After that, we will first make the function for loading the model. So for loading the model, it takes some time. Means we will first call the model, then it will get load. It will get loaded, and the model checks the GPU and the TPU of your current local system also. So it will require some time. So we will use a future async function for this. So I am returning void. Okay. I will name it as load model. You can code along with me, or else these codes will be provided at the end of the session. I will use an async function because there's a future function. So inside this, I will first await the model. Okay, so sorry. I will first use the tf-lite functionality, tf-lite dot load model. So by default, the required parameter for this load model is model. Because we are using image classification task, we have to provide the labels too. So first, I will provide it with the model that is stored in our assets folder. Light. Okay. So this is the model name. Afterwards that we will provide it with the labels too. Labels, assets, labels.txt. Okay. So I have provided this, and this is the function for loading the model. After that, we will have to pick the image to process to give to the model. So for that, I will again create a async function because picking an image requires some time. It requires some buffer. When we pick an image and when we process an image, it requires some buffer. So it will be named as pick image. Okay, same as async function. So for picking an image, first we have to declare, first we have to give a path of the file where the image is stored. So I will declare a variable picked image, which will await. And here we have to use our image picker library functionality. So image picker dot pick image, sorry, pick image. And here we have to give source as the gallery because we are using because we are picking the image from the gallery. Okay. So now we have to check if the image, if the picked image is there or not, or else it has taken some garbage value. Okay, so picked image is null, not equal to null. Then So we will check if the image is not null. So if the image is not null, we will set the state of this file to the picked image. So underscore image is equal to file picked image dot path, and it should not be empty. So I will put an not null constraint there. Okay. So what will it do? It will just pick an image and it will give the path to the image variable that we have created up. Okay. Now for the classification of the image, we will again create a async function. Void image. Okay. And this is going to be also an async function. So in this function, we are going to basically provide the image that we have picked from the gallery, and the image, then the model will run on it and give us the output. For that, first we have to initialize a variable output locally in this block of code. Then we have to call the TensorFlow function to work on an image. So the TensorFlow library provides various enormous numbers of function to us, like load model, detect object on binary, detect object on frame, detect object on image. So now we are going to use run model on image for now because we are taking image. So first we have to give a path for the image. So path would be uh, this image file. So I will give underscore image dot path. Okay. It should not be null. Then the this function also takes some parameters like image mean, image standard deviation, because TensorFlow is a machine learning process usually developed for neural networks. So it takes various numbers of layers. So for taking layers, we have to give various number of standard deviation and mean. For now, I will image mean. I will put the mean to 0, standard deviation to 255.0, because the color scale ranges from 255 to 0, 255, sorry. Then I will give number of results. Number of results basically define how many classes you have. For now, our labels contain 3 classes. So we are going to declare 3 here. Then there is also a parameter called as threshold. Threshold basically tells the model that if I pass the image and if the image prediction is below some threshold, means like if I give 0.5, okay, and the image is below that threshold, then the model will not classify it in that class. If the classification of another class, like if I am giving a car image, it will give classification means accuracy of something about 0.7 to 0.8. So for that image, it will classify it as a car. But for the same image, if it is giving the classification score below 0.5, it will not show that classification. It will go to another class. Okay. So we have declared this variables. So after declaring this, we will check if the output is null or not. Is not equal to null. If output is not equal to null, then we'll set the state of our classification variable where we have to output what what is the type of image, what class it belongs to. So we will output that here. So output variable dot first, sorry, first, and inside this we will classify the label of the image. Okay, this is done. So these are the main three functions. We are first loading the model, we are picking the image, and then we are classifying the image. For loading the model, we have to also define an init state over here because we have to load the model as soon as the app starts. So we will declare init state uh, dot init state, and here I will call the load model. And when we pick the image, we should also call the classify image model. Classify image. Okay. So when we pick the image, it will also call the classify image. As soon as it is called, it will show us the result. Mm, Coming back to the UI part, I will first define a scaffold, set scaffold and nav bar. This is the basic UI which you all will require to run this code. Image classifier. Okay. Title true. Okay. So after that, inside the body, we will sorry, not you. Inside the body, we will first have a center tag. Inside the center tag, we will have a column because we have to display the results in a vertical format. We will give the main axis alignment to the center. Okay. After that, we'll define the children's. Here we have to define some conditions to show the image, and if the image is not present, what should we show? So for that, we will require some ternary operators. So if image is not equal to null, then we will show padding. Okay, padding edge insets are symmetric horizontal 20, and its child as the image from the file path image dot file, and you specify the file path here, that is underscore image dot path. Mm, and it should not be null, or else will mm, take in the input. The path is already covered. Okay, so after this, we are going, or if the image is not null, we will display the image, or else we will basically display a text that will say no image selected. Okay, so this is done. Then we will give a sized box here with height of 20. After that, we will declare the text for the result section. For that, we will again use ternary operator for that classification because the result is stored in the classification variable. Classification is not equal to null. Then we will going to show a text that will say classification is $$ underscore classification, or else it will show a text, select image for classification. Okay, so this code will first check if the classification image result we have or not. If the result is present, then it will show the result as it will show a text. Now for calling these function, we would be requiring a button. So just I will give a size crop. So there is some gap between the buttons. So I will put an elevated button. On press of this function, I will call the pick image function, pick image function that we have defined earlier. In the text, in the child, I will give a text pick image. Okay. So now I will just share my phone screen to show the result of this. I think so my screen is visible. Now I will just run the code from here. Forward to image classifier. Okay. It is taking some time.
I don't see the screen. I only see
Uh,
the Teams shared.
okay, you are not able to see the screen. Phone screen is
Yeah, the
visible,
app.
no?
No, phone screen is visible, but I'm not able to see the app.
Okay, okay, it is running right now. Just a second.
I just shared the full screen.
Okay, okay. It is installing. Okay. So now the app is visible, I think.
Yeah,
Okay.
it's
So if I pick an image, for example, here is a car image. If I pick it, the classification will show classification car. If I pick a ship image, it will show a ship. And if I pick a plane image, it will show a plane accordingly. So these model is currently running on the TF Lite model that we have imported with the help of uh, teachable machines. So this is one way. This was for the task of image classification. If you have any other model like linear regression or any other ML model, like you are using any text for that, so you can basically do something like this. I will show you. I made a simple regression model for house price prediction. So it will display the price of the house according to its area and number of bedrooms. So first I build the model, then I transfer it to the TF-flat model. So while transferring, we have to understand certain condition like the coefficient and the intercept. For linear regression model, the equation is y is equal to mx plus c. Basically, it requires the coefficient and the intercept. So I'm declaring the coefficient and intercept into the custom model, and the x and the output. is giving us the coefficient and the intercept of the custom TF-Lite model. And here the model is generated. So the generated model, I have downloaded the generated model. So the TF-Lite model is downloaded from that. You can use any sort of library like TensorFlow to convert the model, convert a normal model into a TF-Lite model. So I have converted the model into TF-Lite model. Afterwards, after converting that, I have imported it in the assets folder. So this is another code which will predict the house price. Uh, this code basically does that. It has two text controllers. So it takes the area and room. The predicted price is empty for now. And this code uses the tf-lite underscore flutter package. What it basically do is renders your model in your application and puts the result in a map format. For this result, input 0 and input 1, because we have only two inputs for this code. So we are using the input 0 and 1. If you have more input, you can increase the number of inputs here. And I have called the function and I will just run it and show the output to you. It's the class name. Okay. Share my full screen over here. So if I hot restart the model, I think I should get a new response like this. So if I enter certain area like, for example, 1800 square meters and rooms are 5. And when I hit predict, it will show me the predicted value according to the model that I passed there. So this is another way of using the TF-Lite model for this purpose. Okay, we'll just stop sharing from there. So TF-Lite model provides us the functionality to directly dump the model into a Flutter application and use it. So that's all from my side. Getting back to you, Abhishek.
All right. Till now, like, do you have any doubt? You can open up the mic
So,
and speak.
so Vihan has asked a doubt in the chat. What if the classification is above 0.5 or more than one class? Will it consider both? No, because the model is something like you cannot see. The model works like if you are given an image, it will classify the image in one of the classes. You can't classify a single image in multiple class. Okay, so that's the answer for your question.
Any other doubts? Like, anyone?
So,
All right.
no
I'll
more doubts.
just share and I'll tell you about the GitHub repo that we have. Yeah. So this is the GitHub repo that we will be providing. So if you go in the main branch. So the GDSC COCOM have worked on this and we have created different types of machine learning apps here. Like we have this TensorFlow Lite model, which I didn't coded right now, is there in this branch. And the marks prediction API calling was this in marks prediction branch. And there are other branches, let's say as text recognition. So you can read the README and we have provided the reference material and the screenshot of how the app will be looking like. So it just takes an image and apply OCR and extract text out of it. So this has been coded in a similar way. I'll just show you the package used in this. This is the basically the third type of integration that you can do. So this is a TensorFlow machine ML package, and we just read the documentation. You can basically create an instance type and process the image of the input image. And from that image, you get the recognized text. And you can use this text to actually show anything and do anything that you want in your app. This was one of the other way you can use. And so the basically code will be provided and GitHub repo will be provided. Everything is there in this repo. And the speech, we also have a speech recognition here. Yeah. That's all from our side, guys. Like we are open for um, your doubts. Any doubt that you have, then we'll wrap up.
Any doubt regarding how to host the APIs or how to dump your custom models in Flutter?
All right then. No doubts, and we'll end the session.
Okay. Thank you guys.
All right. Thank you.